This video is going to cover separation of variables, which is another way of taking antiderivatives. Typically, it involves x's and y's being mixed together. So in some cases, it might be undoing implicit differentiation, but it's kind of a unique special case, and down the road we'll look at it specifically with exponential sort of models. So like the name implies, we need to separate variables. A lot of times you'll see the x's and y's mixed together. And so generally the first step is to get all the y stuff on one side and the x stuff on the other. So in this case, I need to multiply both sides by y, and I'm also going to multiply both sides by the dx. So again, think of this like a fraction for just a little bit. So if I did that, I would end up, if I multiply by y, I would have a y dy on the left and an x dx on the right. So typically I should show that as my next set of work, and you're going to see that it looks kind of like our symbolism for an antiderivative. All I need to do is add this symbol on both sides, and I guess you could kind of think of it in an algebra sense. Because I'm doing it on both the left and the right side, that's a fair thing to do. But when I put that red symbol in there, that means take the antiderivative. So I'm going to, if I think of the antiderivative of y, or the antiderivative of x, if I raise the power by 1, I'm going to have to get like y squared or an x squared, which means I also need to put that, that reciprocal in front of it. So I'd end up with 1/2 y squared and a 1/2 x squared. Now, I took the antiderivative of both sides, so technically I should add a plus c here and a plus c there. But typically what they're going to say is that let's just bring whatever this is over to this side, just have one number on the right side, and because they're kind of unknowns, we can just represent that with 1 plus c. So a lot of times they don't worry about putting it on the left chunk. Okay, so we just have this. But our goal here is still to solve for y. So I still need to kind of clean up this idea here and get y by itself. So there's some shortcuts that we take here. Again, a shortcut was adding the antiderivative symbols. A shortcut is just kind of putting 1 plus c on the right side. But just remember that we're going to be able to solve for whatever this would have to be down the road. So just think of it as kind of an unknown piece and doesn't always have to follow the correct rules of algebra here. So if I'm going to solve for y, first thing I need to do is multiply everything by 2. Okay, so I'd end up with y squared equals, it's going to equal an x squared, there we go. And then the plus c, it should be 2 times c, but again, because that c is just unknown, a lot of times we kind of ignore multiplying that by 2. It's just an unknown, and it will autocorrect as we would actually use this. Okay, if you have questions on that, I know it sounds a little funny, but just ask in class. Then I want to take a square root of both sides. So I would end up with y equals the square root of x squared plus c. So that may look a little funny, but if we were to actually take this, what y is, and put it in up here, and then tried to take the antiderivative using some other methods, specifically u substitution in this case, you would see that it would kind of work out in that method as well. So it's kind of unique. If this seems a little fuzzy at all, again, just jot down some questions. But I think as we go through a few more examples, this will clear things up a bit. Okay, second example, dy dx equals x times y squared. So again, we need to get things, the same sort of variables on the same side. So I'm going to end up dividing by y squared and multiplying by a dx. So I'd end up with 1 over y squared with a dy equals x dx. Okay, and it might be helpful just to think of it this way. This is really y to the negative 2 power dy equals x dx. And we're really close to being able to say take an antiderivative. Just need to add those symbols on either side, and we can go. So for the left side, if I raise the power by 1, I would get y to the negative 1. And so it's reciprocal. I just put a negative symbol in front. And on the other side, I would have 1/2 x squared plus c, just kind of like we did with the previous example. Okay, and then it gets a little bit trickier from there, but one thing I can definitely do is get rid of that negative symbol on the left side, so we'd have, and what I also might do is that y to the negative 1 power I can write as 1 over y. Okay, this is going to become negative. And then technically the c would have to become negative, but because it's an unknown and it will work itself out in the end with what we're going to use it for, I'll just keep it as a plus c. Okay, now you got to think a little carefully about what you would do with solving for y here. And if you were to think of this as something over 1 maybe, so now we have two fractions, we can actually cross multiply and divide. Or we could just take this entire statement and flip-flop everything. So instead of 1 over y, I would just have, I'll bring this up to the top here. Okay, on the left side I would have y over 1, or just y. And then on the right side would be 1 over negative 1/2 x squared plus c, and I can just leave it like this for now. So that's how I would choose to solve for y. And again, we can go through some other methods. Now that I know what y is, I could take this, plug it in right here, and see if I could work backwards from there to figure out, you know, if I would get the same answer undoing the derivative in a different manner. And we would, okay? But this is just an easier way when it starts out in this form. Okay, last example that I'll do with you. Now it's going to be dy dx equals 4x times y. So again, we separate the variables. So I have to multiply by a dx and divide by a y. So I would have 1, there we go, 1 over y dy equals 4x dx. So I just need to put in those symbols here. And we're ready to take an antiderivative. Now remember, the antiderivative of 1 over y, in this case would be the natural log of y, and technically I should have absolute value around that. Antiderivative of 4x, well, the x will get raised to the second power, which means I would multiply by 1/2. Well, 1/2 times 4 is 2, and then I have a plus c there. Okay, so how do I get rid of that natural log thing? Well, I can make e the base of both parts here, and so that would really get me, come on, okay, I'd have y equals e to the 2x squared plus c power. And I know we still kind of have these absolute value symbols here. I'm just kind of an informal way of explaining this. If we were to think through our power rules a little bit, instead of adding these separate powers, I could really write them as e to the 2x squared times e to the c. And so this absolute value stuff right here, you know, it's going to make things over here positive or negative. I can just determine what this unknown piece is going to be later on, positive or negative. And so that technically allows me to get rid of the absolute value symbols and just say that my overall answer is, typically we bring that e to the c out front, times e to the 2x squared. Again, this is a c right here, looks a little messy. And that's generally how they leave that answer. I know that's going to look really gross and you're not going to like that answer, but just at least copy it down again, jot down some questions. But if we were to plug this, oops, get my pointer there. If I were to plug this equation back in for the y up here and then tried to undo some of this stuff, you would find that it would work out and get to this in another way of doing antiderivatives as well. Okay, two more examples. I want you to try them on your own, so I'll put them up there on the screen for a couple seconds and then have the answer, the solution up there for a few seconds. I want you to try this process on your own, please.